Good morning to all of you. So, in the last lecture, we were discussing about pre-processing techniques, where we perform the scaling, normalization, these mathematical operations. Plus, we discussed about labeling, where the strings were labeled into numbers, and whenever we require, we can convert those numbers into strings back. That is decoding process. First we encode, and after that, if we want, we can decode. Using some set of data, we can learn that how the encoding should be for, say, n unique classes. So n unique classes, if they are strings, then there are some n unique numbers which represent those classes. These things we have discussed. And before beginning with the classifier section, I just want to discuss these few things about data preprocessing. So there are missing values in data. Okay, so if there are outliers, how to handle them? Now we know that we can use L1 normalization, we can use L2 normalization, we can do the mean removal process, we can do the thresholding, and then we can process the numeric data. Well, if the data is non-numeric, then we can convert it into numeric using the label encoding method. But what if there are missing values in the data? So initially we identify the missing values in the given data set. When we import the data set, we check whether some values are missing or not. We can do it with the help of metadata information and exploratory analysis. So what is metadata? Say there is some file. Along with that file, we have some additional data available for us. That is the metadata. So it will tell us how many rows are there, how many columns are there, how many bytes per instance or per value. Like this metadata is available with good data set, good quality data sets. If it is not available, then we can do the exploratory analysis. Means we can ask that in this particular column, how many missing values are there? In this particular row, how many missing values are there? Once we are aware about the missing values, we have to decide whether we will replace the values or we are going to drop these values. So decision is up to data scientist that which rows are to be dropped or which rows are to be filled up. Say there is a row. Okay, I'll explain this with the help of paintbrush to make it more clear. Say this is a data set. In this data set, there are some features like feature 1, feature 2, feature 3, 4. Okay. So there are some values available over here. See, the values are 10, 2, 5, 8. Likewise, there are many rows. There is one row. Likewise, there are many rows. In one row, the values are like this: missing value, 1, and then all missing values. Okay. So if this is the row with only one value available for feature 2 and all other values are missing, it is good to drop this row, right? Because see, only one value is available, all values are missing. We have to change the values. So instead of that, we can drop this. There is another row where the values are like this. It's 2. Okay, so this is only missing. So we can use some technique to obtain this value. Guess this value. Okay, because other values are available, it is okay to fill up this missing value. I hope you got the scenario over here. When to fill up the missing values and when to drop the rows. So we will drop this row. We will fill up the value over here. All right. So it also depends upon how many missing values are there. Like here, so many missing values, 4 missing values were there. Here only 1 missing. So this is small data set. Like you may have the data set with more number of features. So this is one Python code. Here NumPy is imported, pandas is imported, and here the data frame is constructed using numpy.nd array. We provide a list over here. In this list, 50, 70, 80. These are the numbers. Then this is NaN means this is missing values, not a number. So we are just reserving the memory space, but we don't know what is the value at that particular position. How many values are there over here? Just we'll count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 values are there. Can we rearrange them? Yes. The command is .reshape, and here we can tell how many rows and how many columns. So 5 rows and 3 columns. In this way we arrange. So the 3 columns are there. To those 3 columns we can give the title like feature 1, feature 2, feature 3. Any doubt, any query in this?
No, sir.
So next is if they are if they are completely random, they cannot give any extra information and can be omitted. So this is about missing values. On the other hand, if they are not at random and the fact is that a value is missing is itself information, then we have to fill up the value. So in the data, so we can know where the missing values are situated. Rows or columns with too many, so here too many meaningful missing values can be deleted from your data using pandas drop in a function. So here axis 0 is for rows, axis 1 is for columns. Axis 0 is for rows. So if you want to perform the operation along rows, you will set axis is equal to 0. If you want to perform it along columns, you will say it 1. Then threshold. So here number of non-Indians not to drop a row or column. Okay, so here the threshold will be there on number of non-Indians, and then in place means update the frame there itself. Update the frame there itself. So here these are the commands available in pandas. So after removing rows with all missing values, so say you want to pre-process the data. First is drop NA. So drop NA just we discussed. Here we can see too many non-meaningful missing values are there, then we can use drop NA function. So this drop NA function, axis is equal to the 0 means along rows. Threshold is equal to 1 means what? Number of non-NANs is 1, not to drop a row or column in that case. Then in place is equal to true means this data frame will be updated. Then reset index. Reset index means what? Say this is a data frame. Say this is a data frame. It has some index. Like this is index 0. Here it is 1. Here it is 2. Here it is 3. Here are missing values, suppose, and you drop this. Now the index becomes 0 to 3. Okay, but we don't want 0 to 3. We want to update it. Okay, so how the updated index will be? 0, 1. So this is dropped. Earlier, the index associated with that is also dropped. So that's why it is reset index in place is equal to true. Then suppose you want to drop by some index value you want to drop, then you can do that. Okay, so this is the dot drop command. Using that we can do it. Then there is one operation where we can add the features. So here Say the data frame is feature 1, feature 3, and there are rows of information in it. Now this data set is not sufficient. Number of columns, number of features are not sufficient, and it is not giving us the good accuracy on certain classifier. So what is the alternative? Alternative is to change the classifier. So this is one way. Just bring some advanced classifier or another classifier. Another way is hyperparameter tuning. Try to change the parameters of. Okay. In the classifiers, you try. You're not getting the better accuracy. Features are there. That's why my classifier algorithm is not learning well. You can add the features. Okay, and those features can be. Okay, so these features, say this feature 4. This feature 4 will be polynomial combination of this feature 1, feature 2, feature 3, or some of them. Okay, so this is called as derived feature. Derived feature. So F4 and F5 will be derived features. So addition of polynomial features to the dataset. Creating polynomial features is a simple and common way of feature engineering that adds complexity to numeric input data by combining features. Polynomial features are often created when we want to include a notion that there exists a non-linear relationship between features and target. So if we think that there should be some non-linear relationship, you can add these columns. They are mostly used to add complexity to linear models with little features, or when we suspect the effect of one feature is dependent on another feature. So in scikit-learn, it has the code for polynomial feature addition. So polynomial features is a class to create polynomial features from scratch. The degree parameter determines the maximum degree of polynomial. Okay. Degree parameter determines maximum degree. For example, when degree is set to 2 and when x is x1, x2. So these are the original features x1 and x2. So here in this case, f1 and f2, these are the original features. And when degree is set to 2, which features are generated? So column 1 will be generated. So in 1, all the values will be 1. Then x1 as it is, that column will be x as it is. Then x2 as it is. Then x1 square. So square of the values contained in this column, it will be generated x1 square. And then x2 square. So square of values in x2 column, they will be generated. And then x1 into x2. So these columns 1, 2, 3, 4, 5, 6. 6 columns are the result of this operation, in which the x1 and x2 were already there, already with us. Then there is one option, interaction only parameter. So let the function know we only want the interaction features. Okay. So interaction features means 1, x1, x2, x1 into x2. So it will not find the square. Interaction features are these one. This is the interaction feature, and these are by default features. So later on we can drop them if you want. Like one is not useful many times, but this is useful feature. And if you want advanced features, you can have this. Okay. So here we create polynomial features to the third degree and only interaction or interaction only feature. As a result, we get 4 new features. So if degree is 3, and these 2 polynomials are there, x1, x2, or f1, f2, then we can get 4 new features. So here, suppose we have three different features in original, and then we can get the four new features: f1 into f2, f1 into f3, f2 into f3, f1 into f2 into f3. So these four features with interaction only as true, we can obtain. Note that our original features are also included in the output, and we slice off the new features to add to our new data later. So this is possible. Next is categorical features. So this was addition of features using polynomial feature strategy. The next is categorical features. So here also we have to pre-process this type of feature. Munging categorical data is another essential process during data pre-processing. Unfortunately, scikit-learn's machine learning library does not support handling categorical data. So yesterday we discussed a bit of it, like level encoding. Before you start transforming your data, it is important to figure out if the feature you are working on is ordinal as opposed to nominal. Ordinal feature is best described as a feature with natural ordered categories. Natural ordered categories, and the distance between categories is not known. So once you know that what type of categorical data you are working on, you can pick a sorting transformation tool. So there are various tools that are available with scikit-learn. Ordinal encoder is there for ordinal data, and one hot encoder for nominal data. So nominal data is typically numerical data, you can say. Nominal means numerical, you can say, and for this you can have this one hot encoder. For ordinal data, like data arranged in a list, which is non-numerical, it is natural ordered data. So for that you can have ordinal encoder. Okay. So we'll have a quick break of 5 minutes, and then please come back at 8:30. So till now we saw the theoretical basis of this data pre-processing. Now we will discuss about some demonstration. So here there is one Google Colab notebook. Here import NumPy and pandas like this. Then the same data frame that we discussed, the same data frame or similar data frame, it is constructed. 21 element, more missing values are there. So here you can see this NumPy array. It is made up from a Python list, and then it is reshaped to 7 rows and 3 columns like this. The name of the data frame is my_mat. So if I execute this, I can see 7 rows are there, 0 to 6, and 3 columns are there. Feature 1, feature 2, feature 3. Here you can see in NaN values are there. Missing values are there. Now, when I issue the command my_mat.drop NA, axis is equal to 0, threshold is equal to 1, in place is equal to true, what happens? So let us check. If there are 3 missing values, it is dropped. So row 1 is dropped. If there are 2 missing values, it is not dropped. If there are 3 missing values, it is dropped. So threshold is 1. So at least one non-missing value should be there, then it will be retained. Otherwise, it will be dropped. Okay, so this is retained. Then this row number 5, row number 6 actually 0 to 5. So row number 6, it also had all the missing values, so it is dropped. So you can see index 5 is missing. So index 0 to 3, 4, 6, it is there. Okay. So effectively, we got these 2 missing values in this data set. Other rows are dropped. Okay. Next is reset index. So now, after dropping those 2 rows, what is the index? 0, 2, 3, 4, 6. Now we will reset the index, because how many rows are there? Effectively 1, 2, 3, 4, 5. Now 5 rows are there in our data set. So the index should be 0 to 4. So let us do that. Using reset index command, in place is equal to true, and now check the data frame like this. Okay, so the index is also there. Old index is retained and this new index is assigned. Okay, but we don't want this index column. We don't want this index column because we have the new index available with us. So let us drop that. So my_mat.drop, name of the column is index, axis is equal to 1, means column wise, and drop it. So these are the features. These are the new index values that are available to us. Index column is dropped. Any doubt, any query in this?
No, sir.
Okay, okay, thank you. So let us proceed. Here we will import the missing indicator. So this will tell us the missing values. If they are NaN, then it will tell us. So it is imported. Then there is the object that is created for this missing indicator. Then .fit transform. It will transform the my_mat on this. It will show us that which are the values that are missing. So here we can see that it is saying true, true, and so here it finds true in this column, in this column. So here column information is missing, column information is missing, but along rows we can know that there are missing values. Then this command can also be like in the entire matrix if there is any missing value. Okay, dot any. So true means yes, missing value is present in this particular data frame. Next is so this command is null. This will tell us the information column wise. So earlier we lost this information, like column information is lost. Only it is saying true, true. But what about this column? Here the information was there. it was not missing. So if we use these commands, mymat.isNull, then if we print it, we can check that here it is true, here it is true, and here it is false. Okay, so this is more appropriate representation of null values. So from this we came to know that missing values are present. So we have to handle these values. So for filling up missing values with common strategies, scikit-learn provides a simple imputer. The four main strategies are mean, median, most frequent, and constant. In the example below, we will impute missing values for our data frame, mymat, with the features mean. Okay, strategy is mean. So simple imputer, it is imported. Missing values np.nan, and strategy is mean. And this is the object that is created with these parameters. Okay, telling that strategy should be mean, and then transform mymat. Okay, so let us execute this, and this value is filled up. Okay, this value is filled up, which is mean of all other values. Mean of all other values. Okay, so for example, okay, some calculations are done. Here you can do the calculations. 5 minus 5 plus. So this 7.75. This was filled up over here. Okay. For all other values, we find the mean, and this value is filled up over here. Similarly, for these. 24 minus 14 plus 14. 8. So that is filled up over here. Okay, so this is the mean strategy using which the values are filled up. Next is median strategy. So to calculate median, we have this website. Here we can enter the data. What is the data? 5 minus 5, 19, 12. 5 minus 5, 19, 12. So median is 8.5. Okay. So just a minute. So if I execute this, and then if I print Z, which is transformed using median, here you can find 8.5, which can be matched over here. Okay. Similarly, for this data, it is 11. So it is median strategy. Next is we can assign column names like this to Z, F1, F2, F3. Here you can write any text or column heading, and then we can print the final data frame where the missing values are filled up like this. Any doubt, any query? Next is polynomial features. So here the polynomial features function, it is imported from preprocessing module, and then we are saying degree is equal to 2 and interaction only is true, and then we transform the Z data frame. Z is passed over here, then we transform command is issued and print polynomials. So here the 1, 2, 3, they indicate feature 1, feature 2, feature 3. Okay, and column 0, it is always 1. So we saw it is always 1. Interaction, so F into F2. So here you can have 35, 11 12 into 19 to 20. Multiplication of feature 1 and feature 2. Okay. Then this column 5, it is multiplication of feature 1 and feature 3. 8 into 5, 40, like that. Okay. And this last one, it is multiplication of rest of the two, like this. So we can have this polynomial features. Interaction only is equal to true, that is multiplication, and these columns can be dropped. If you want, you can drop, or this 1 1 1 1 is constant information, so you can drop it. Next is total poly is equal to, here we perform the concatenation. So this was the original data frame, and these are the polynomials. Like this. So feature 1, feature 2, feature 3, and this 1 1 1 1 column. These are repetitive features, so this can be dropped. So 0 1 2 3, these columns can be dropped, and these can be retained. So to drop a column, the command is drop. Okay. Here somewhere syntax was mentioned. Yeah. Here you have to mention the name of the data frame dot drop, and here in square bracket just name the column. Axis is equal to 1, in place is equal to true. So it will drop that particular column. Okay. So this is after dropping this, what we get is these 3 features, they were already there, and these 3 features, they were introduced by us. These are called as derived features. It's very important. Like if you want to design a model, and if you're not getting the sufficient accuracy at that time, you can include the derived features like this. There may be polynomial features, there may be some features that depend on some mathematical calculations. You can do that. Next is, so here is another example. Here the polynomial features are imported, then np.arange 6 3, 2, like this. So this is the data 0 1 2 3 4 5 is created over here. Then polynomial features 2. So here you can see the polynomial features are generated. Degree is equal to 2. So what it will generate? X1 square, X2 square, and X1 into X2, so and 1. So this 1 is there, this column 1. Then 0 to 4, another column. 1 3 5 is another column. Then this X1 square, so 0 square 0, 2 square 4, 4 square 16. This column is there. Then 1 square 1, 3 square 9, 5 square 25 is there, and then X1 into X2. So 0 into 1 0, 2 into 3 6, 4 into 5 20. So if you say interaction only is equal to true, then only these square columns are omitted, otherwise they are included. When we say interaction only is equal to true, what happens? Just check. These columns, the square values, like this one, this column, and this column. Okay, this one and this one, they are missing over here because we said interaction only is equal to true. Any doubt, any query in this polynomial features?
No, sir.
Okay, we will proceed. Next is handling categorical data. So here, say the data is like this. First, we will import pandas and numpy. Here, the data is available in the data frame. How many values? So 15 values are there. We can reshape it as 5 rows and 3 columns. So here is the data frame, 5 rows, 3 columns. The column names are 0, 1, 2. Okay, we can assign column names like earlier we assigned the column names. So gender, blood group, and INC level. Okay, so these are the column names that are assigned. Then we can again print X, which is a data frame like this. So these column names are assigned. Now what we have is a data in a string format, and using ordinal encoder we can fit this data. Say ordinal encoder, this is imported. Then this object of ordinal encoder this is created. Here we pass the data frame X. So this passed to the fit transform, encoder.fit transform. And we are discussing about INC level values, reshape -1 to 1. So let us see what happens. So these are the INC level values: low, medium, high, and not number. So just check. For not number, it is assigning the number. Means what? We have to remove this NaN. We have to remove this NaN before proceeding for ordinal encoding. So we have to either we have to fill up the missing value, or we have to remove this row. That care we have to take, that we should not have any NaN values. So this is for demonstration purpose. Now in this we have low, high, and medium. So for them, the numbers are allotted. Like for medium, it is 2. For high, it is 0. And for low, it is 1. So these numbers are allotted by this ordinal encoder. Okay. By this ordinal encoder. So here we can do one thing, that is by removing this. Again, say this is low. Again, proceed. So it is removed immediately. So for low, it is saying 1 is a number. For medium, it is saying 0, and for high, it is saying 2. So these numbers are allotted by this ordinal encoder. Next is one hot encoder. So let us see what happens. Over here, one hot encoder object is created, int type, and then there is the data frame. Here, gender and blood group is present. Then if we convert it, here you can see the male, female. Okay, so what is male, female? Gender. So male and female, these values are there. For this, we can have the two columns. Like if it is male, it is never a female. Okay, so 0 1 0 1, then 1 0 1 0. Just observe the original data. So it is male, male. So for that, it is 0 1 0 1. So male column will be 1. Then next 3 rows are female. So for that, it is 1 0 1 0 1 0. Female column, it is 1. Rest of the values over here are 0. Okay. So like this, we can have the numeric feature. So there is one hot encoding. Originally, there was only one column, gender. From this, we generated two different columns because there were two possible values available in this column, male and female. So if there are three possible values, three columns will be created, three numeric column will be created. And wherever the corresponding values are there, that column that value is set to 1, and rest of the values are set to 0, like this. Okay. So this was for gender, and then for blood group, there are 4 possible values over here. So for first person, say gender is male, blood group is O minus. So wherever O minus is there, that value is set to 1. Rest of the values are set to 0, like this. Then in next row, it is O minus, again that is set to 1. Rest of the values are 0. Next it is O plus. So for O plus, there is the column, so this is set to 1. Rest of the values are set to 0. So likewise, the numeric data is generated. Just observe, earlier entire data set was in text format, string format. Now the entire data set is in numeric format. Now it is good to be processed with the help of scikit-learn library classifiers. Okay. So let us experiment with the data set. This thing we'll cover later. I'll show you demonstration that how on a data set we can do the pre-processing. So in next lecture we are going to cover this part. Any doubt, any query regarding this? Okay, then we will stop here. I will download the attendance list. Thank you for attending the lecture. Bye bye.